Hello everyone, I am Vishal Chakraborty and today I am going to solve few problems of Kirchoff's current law, which is nothing but KCL. So let us go with the first question. The first question is determine the value of current flowing through V1 and V2 in the given circuit. Okay, so the first given circuit is it is on our screen. So let us start the question with a few steps. Firstly, let us see what is actually KCL. KCL is a law which states that whenever there is a junction in a electrical circuit, the entering and leaving current should be algebraically zero, or else we can say that the algebraic sum of the entering and leaving current should be equals to zero. Okay, so in this case we take I1 plus I2 plus I3 is equals to zero. Now we need Ohm's law to solve this question, which is nothing but V equals to IR. Okay. From the same formula, we can derive I equals to V by R, which is nothing but current is equals to potential difference by resistance. Yeah. Okay. So now, so to solve this question, firstly, we need to see how the circuit can be redesigned and made more proficient to solve. Okay. So now, as you see, there are totally four junctions or four nodes here. Okay, but two of the nodes are equipotential nodes. So to make it more simple, we can merge this node in one node. Okay, so after merging it, it will look like this, which we can name as G. Right now, it has four branches, and we can give this as a ground support or a ground node. So totally, we have no three nodes: V1, V2, and G. Okay, now when we go to the solving of problem, firstly, we go for the V1 node. Okay. Now the V1 node is this, and it has three branches. Okay. Now we assume that V1 has the highest potential in the whole circuit. So the flow of current will be from V1. Like every current in every branch, current will be leaving from V1. Okay. So the flow of current will be from V1 to G. So this will be the direction of current, right? Left way. Okay, and to find the potential difference, we will be writing V1 minus 30 because this is higher and this is lower. We have assumed that V1 is higher in the whole circuit. So obviously this will be lower than V1. So V1 minus 30. Yeah. So after getting V1 minus 30, we divide it by resistance. V1 minus 30 by 15. Okay. Next we have V1 by 15. Why we got this is V1 minus lower potential difference G, which is nothing but 0. So V1 minus 0 by 15 ohms. Okay. So next we go for the next branch this. Now higher minus lower V1 minus V2 by 2.5 equals to 0. Now this is the equation we get for I1 plus I2 plus I3. Substituting I equals to V by R. Okay. Now when we simplify this, we get the simpler equation this. Now at node V2, how we solve is in the same way, firstly we take the first branch and we take V2 minus G, nothing but node to node. V2 minus G is 0, and we have potential difference in between. So V2 minus 50. Okay, V2 minus 50 divided by 20 ohms. Okay, so this is the I3 we took. We took the I3 as this branch. Okay, so V2 minus 50 by 20. Now let's go for the second branch, which is V2 V2 minus G by 20. G is 0, so again V2 by 20. Next one is again V2 higher to lower. We assume in this case we assume V2. For the first node, we assumed V1 as the higher potential in the whole circuit. Now we are assuming V2 as the highest potential in the whole circuit for node 2, for the solving one node 2. Okay. So now V2 minus V1 by 2.5. Okay. Now when we simplify this equation, we get simpler equation as this. And when we solve these both equation, we get V1 value as 18.75 volts and V2 value as 20 volts. Okay. Now, now we have been asked to find the flow of current from V1 to V2. So in this branch, it's nothing but I3. So now we can take it as V1 minus V2 by 2.5. This will be our equation for finding the current. Okay. But we have already seen that we assumed that in one case V1 is higher, in another case V2 is higher. But after solving, we got that V2 is higher than V1. After solving, we got this value. Okay, now when we substitute V1 and V2, we get the value of current as minus 0.5 ohms. Why we get minus is it shows us the reverse direction or the negative direction of the current, which is nothing but now we took as higher potential to lower potential. We assumed that V1 is higher and V2 is lower, so V1 minus V2. But actually, we got in the after solving is V2 is higher. So actually the direction of the current will be in this direction, V2 to V1. But we took in this equation, we took it as V1 to V2. So we got in minus value. If we take V2 minus V1, we will be getting a positive value of current. So this is the first question. Now let's go to the second question. We will solve in the same way. Here we have directly current source. We have directly current source in this. So for solving this question, it is a lot easier than the previous one, because we will be substituting direct current sources. No need of transforming by V by R again and again. So again, using KCL and Ohm's law, we'll be solving for the node 1. For the node 1, we have this. Okay, for the node 1, see, again we assume that V1 is higher, and V1 is highest in the whole circuit. V1 has the highest potential in the whole circuit. So the flow of current will be this way, left side. But we have been given that the direction of flow of current is this way. Okay. So as they are in opposite direction, we take the negative of the current. Okay. So minus 4. Directly we substitute I1 as minus 4. Next, again we take V1 by V1 minus G by 2. Okay, but again G is 0, so it is V1 by 2 ohms. Okay, for the next branch we can take V1 minus V2 by 4 ohms. Okay, so this is the first equation. When we solve it, we get something like this, a simple form of that equation. Now at V2 we do the same thing. Again, V2 is higher and G is lower, so we take V2 to VG, V2 to G, the direction of current, but we are given it is in opposite direction. So we take again minus 8, again V2 minus G by 8, or else V2 by 8, because G is 0, and again V2 minus G, V2 minus V1 by 4 ohms. Okay, because now we again know that we are assuming here in each node that wherever which node we are solving, we are assuming that node has a higher potential. Okay. Now after solving these both equations, we get the value of V1 as 16.05 volts and V2 as 32.11 volts. Okay. So this is my PPT. So thank you for being with me.